Hello students! By now, we know what hydrocarbons, alkanes, alkenes and alkynes are, and also with what functional groups and how they determine the properties of these compounds. We have also seen in detail about alkanes and alkenes and how to name them. We know that the name of any hydrocarbon compound is made up of two parts: the root, which indicates the number of carbon atoms, and the suffix, which indicates the type of bond. For example, ethane has root eth, which means it has two carbon atoms, and suffix ane, which means it has all single covalent bonds. Now, if I tell you the compound has 5 carbon atoms and 1 triple bond, what will be its name? Yes, we know that 5 carbon compound has a root called pent, and since it has a triple bond, it belongs to the family of unsaturated hydrocarbon alkynes, and thus the suffix -ine. So the name will be pentyne. Now what if I attach the alcohol functional group to ethane or the aldehyde functional group to pentyne? Would they still be called the same? No, isn't it? So then let's study how to name a compound when one or more functional groups are present in the hydrocarbon chain. Do you know that in ancient times, carbon compounds were named after the natural substances from which they were derived? For example, formic acid. And do you know where we got this acid from? Yes, initially it was obtained from red ants. And in Latin, these ants were named formica. As a result, the name formic acid was given to them, derived from its Latin source. With the passing of time and advancement in science, we were able not only to extract naturally these organic compounds, but we were also able to synthesize them in laboratory artificially. Therefore, now there was a need for scientists to determine a systematic method for naming these newly synthesized carbon compounds, because there were n number of compounds that were synthesized. Now this is where IUPAC stepped in. It is an abbreviation of the International Union of Pure and Applied Chemistry. It sets rules for naming various carbon compounds scientifically. According to these rules, the IUPAC name of any organic compound or any carbon compound has 3 parts: root word, prefix, and suffix. The root word gives the number of carbon atoms present in parent hydrocarbon. Now, what's the parent hydrocarbon? It is the principal chain of the hydrocarbon compound that has the maximum number of carbon atoms and has functional group attached to it. Remember students, it should have maximum number of carbon atoms. These are the root words for hydrocarbons containing 1 to 10 carbon atoms. Say if compound has 1 carbon, the root is eth. If it has 4 carbons, the root is bute. If it has 3 carbons, the root will be prop. Do you know that most of these root names are taken from Greek numerals except for the first 4? In Greek, pent means 5, hex means 6, and so on. Now the prefix that we add along with the root word represents the heteroatoms, branches or bonds present in the parent hydrocarbon chain. This table shows the relative prefixes used for heteroatoms or groups attached to the parent chain. So if a halogen atom is present in the carbon compound, we use the prefix like fluoro, chloro, bromo, and iodo for iodine. Or if any alkyl groups are present, we use the prefix methyl, ethyl, propyl based on the number of carbon atoms. For example, consider this carbon compound. How many carbon atoms does it have? Yes, 4. So the root word for it will be bute, isn't it? Yes. Also observe that it has chlorine attached to 1 carbon. Thus we will add chloro as a prefix to the root word bute. Hence, 2 parts of the name of this compound are chlorobute. Now what about this suffix here? Whether this compound is butane, butene or butine, or will it have OH or all or oic acid? To answer this, we will have to see the third part of the name. The third part of IUPAC name is the suffix. As the name suggests, it forms the end of the name. It is divided into two parts, such as primary suffix and secondary suffix. The primary suffix comes immediately after the root word. It represents the type of bond present in the parent chain. For example, if all the bonds between carbon atoms are single, then suffix "-ane" has to be used. And why so? Because it will be the member of alkane family. Similarly, suffixes "-ene" and "-ine" are used for compounds containing double and triple bonds respectively. While secondary suffix describes the functional group of the compound. The table shows different functional groups and their relative suffixes. For example, alcohol functional group will have -ol, aldehyde as -al, and ketone as -one, and so on as suffixes. So we are going back to our compound. Yes, we were to decide its suffix, isn't it? Yes. So as you can see, all carbon-carbon bonds are single covalent bonds, and therefore the primary suffix would be "-ane". And since there are no other functional groups, there will be no secondary suffix. Therefore, the suffix will be only "-ane", giving rise to the name chlorobutane. So what we have seen is that there are three parts in the name of any compound. Thus, these parts are joined in the following order to get IUPAC name of the compound. That is, first prefix, then root word, and then suffix to get the whole IUPAC name. But how can we get the name of carbon compound in this way or with these rules? We will see in our next video.